Today we're gonna kick the tires on this brand new HTP Mig 2800i. We're gonna weld all the way from 40 or 45 thousandths to 80 thousandths, 1/8 inch, 3/8 and 1/2 inch material. We're gonna use 035 solid wire, 75/25 gas, and we'll see how the machine handles welding really thin material or really thick material, what it sounds like, what makes this machine different than any machine you've used before, and is it gonna be better than what you have in your shop right now. So let's take a look at it. So here, this is our manual mode, front and center. There's a door chart in here. You can adjust your own wire feed speed and your own voltage to your liking. If you prefer short circuit all the way across the board, the typical bacon frying sound, this is where you want to be. I'm going to show you what this machine does in a program. Here's our program list. Carbon steel, 75/25 gas, 035 wire. And then here you have material thickness. We're going to be at 45 thousandths roughly. And this is your voltage. This is your wire speed, predicted amperage, arc voltage, rough guesstimate on material thickness for in position welding only, not out of position. And then here, this is your trim. You see this will make your arc softer or crisper depending on how you adjust your voltage. So I'm gonna run with this on some 45 thousandths material and see what we're gonna get. So I got a test piece here. I'm just gonna run a bead across it and then I'm gonna join two of them. So this looks a little bit crowned and cold, maybe not. Maybe we give it another 10 or 15 inches a minute on the wire speed and bring the power level up a little bit. Let's run another test piece here. So that arc ran a lot more stable and smoother. Now, why do we have this? Why weren't the machine settings correct right out the box? Well, this is a 5/8 plate that's laying on here, and it's ice cold, 60 degrees at best. So if you have your piece of metal laying on that heat sink, it sucks the heat right out of the weld joint. In order for those settings to be correct, I should have probably propped this up in the air and then the first setting would have been right, but that's where there's a little bit operator variance. Also, what I would like to show you is this machine in the programs also has the ST arc function, which you can hold your MIG gun wherever you want. If you have enough shielding gas, it will compensate the settings for you. So there was an 1.5 inch stick out in here and it compensated just fine for it. So now let's go and join two pieces and see how that works. I'm gonna have a real life scenario, some mild surface rust here on the end. If you look at this here and you look at the bluing, it just like creeped out a little bit more. There's not much material to like hold the heat. But when you look at this, this is a full weld. Nothing is really bleeding through. Looks nice, virtually spatter free. So that is where this machine shines over some of those old machines like the Mig 2400. So now let's bump it up. Let's weld a little bit thicker and see what it does. Nice narrow heat affected zone, narrow bluing zone. The bead lays down perfectly flat, nothing is crowned. You can see it came through just enough to get a full penetration weld without joint prep on this. Now let's bump it up to 1/8 inch. So this one here is actually 10 gauge, I believe, 135 thousandths thick. And I go right to the 10 gauge setting. Now would you look at this? Absolutely no spatter, no BBs flying around. The art never stopped on this nice, crusty, rusty material. Something you would find in your shop that has laying on the water table for the plasma cutter a little bit too long. You have your milk scale on, you have a little bit surface rust on it. Not crazy, but just enough to mess with things. And this was an unprepared plasma cut, and it basically filled most of the joint just with that 60 thousandths curve that it left in there. So no, the machine is not irritated by welding over the plasma cut, which the results for what we started with are absolutely amazing in my mind. So now, I've played with this before. When you go to 1/4 inch, things change. You're coming all of a sudden out of this short circuit, and you get into, depending on what gas you use and how your settings are exactly, but you skipping globular, you go straight to spray transfer. So of course, this is no good if you weld out of position, but then on the other hand, if you weld in position, we're at 283 inches per minute now on that 10 gauge setting. That would typically be a good setting to run vertical up on something thicker like this, like 3/8. And we can do this, we can tack this together. We can tack this together and we can weld some vertical up on this. So when you look at this already looks like I was very ambitious, had a lot of wire feet there. It doesn't look nice and smooth. That's your root pass. I know I have good penetration in there, but my toes are really cold. The second pass should smooth this out. I probably should limit it to about 250, no more than 270 inches per minute going vertical up, but I'm at 283. I'm going to try to wing it now. So the second pass looks so much nicer now. So that just goes to show you that even though the machine says 10 gauge, just over 1/8 inch, that's about the most you want to weld vertical up. No matter how thick your material is, you may have to preheat a little bit. With that solid MIG wire, that 035 wire, the machine just doesn't, the material just doesn't take any more liquid puddle without material rolling out and dropping off. Now, if you do this in a flat position, let's show you what happens when we do this in a flat position. In a flat position, going up to 3/8 material thickness, which is at 590 inches per minute for a single pass. Standard machine settings, no deviation on the voltage. Listen and watch what's happening. So this clearly was 100% spray arc. Now you do see a few BBs down here. Again, intentionally, no prep, no anti-spatter spray. The reason you see those BBs here is because you hear a couple pops and cracks. That's the 75-25 gas we're running. If you run at least 80% argon and less than 20% CO2, you don't have this, you get into a clean spray arc. That is the difference between being able to get into a clean spray arc with the proper gas or using 75-25 gas. I mean, nothing that a grinder wouldn't take care of, nothing that some anti-spatter spray probably wouldn't have taken care of. And you see the nice silicone eyes on top of the weld. If you knock those down, a perfect clean MIG weld under it. No undercut really. And if you had thicker material to do, you would just do multiple passes. Now, of course, spray arc is only good in the flat position. This was horizontal, so my weld droops a little bit towards the bottom. I got away with this on this material thickness in a single pass. If I was gonna build this up now, I probably would have to reduce my settings to get the weld put in further on the top. Or here, in this case, I can rotate my part, which of course I couldn't do if this was on a machine that is bolted down to the floor. So that one went in really nice. No undercut, less BBs. I kind of had my gun angle figured out now. And the arc length was about right too. And once you're in spray arc, your voltage deviation, your trim, like your number you dial in with your right dial, that is the one that determines your arc length. More voltage is a longer arc, more swirling around, wider, less penetrating, wets out, maybe nicer, but your goal should be to trim the arc down, shorten it up to where it's nice and focused, where you don't heat up the whole part, you just heat up your weld joint. So trim your arc to a spray arc still like short and focused if you can, and don't let it wander around and have an arc that is like 1/2 inch long. Even 1/4 inch long is too long. Between 1/8 and 3/16 maybe. So that was our demonstration on the Mig 2800. That sums it up. You'll like the way how it welds or you won't. If you don't like it, if you're more that short circuit transformer guy, go back in the manual mode, go by the door chart, and you will have the sound and the way how it welds like you have been used to. If you want to get deep penetration in material that is maybe a little bit cruddy, had some surface rust or some mill scale on it, and if you're in a situation where cleaning is either not possible or not cost effective and you still want to weld, there you go. That is your solution. All right, thanks for tuning in. See you later.